Hi again, class. This is our second class for Wednesday, and then, like I said, I'll have another class on Friday. Um, so, uh, I've reminded you a couple times on the posts that I'd like you to submit your work when I specify that I'd like you to do that. So, like with this practice quiz, um, it, I need to take in some of your work as far as marks is considered. Uh, so, um, so you need to be uploading these on the assignment section. And so there's been a variety of ways that you've been doing that, but most of you seem to be um, just basically taking a picture and then putting it up there, which is great. Okay, and I can look at that then. The other thing is you do want to be prepared for when we get back into class, hopefully, or if not, be prepared for first year university and college. I know many of you are probably going to be taking first year chemistry, so the stronger you are in Chem 12, it'll definitely pay off. The other thing was that I wanted you to be asking me questions that you'd like me to go over um, from the unit. I didn't get anybody asking any questions, so um, I'd like to see you do that. It helps for me figuring out what needs to be re-explained, or what you're finding confusing. So please make sure that you send questions my way, and then I can begin class by going over it. So what I like to do today is basically go over the practice quiz. So you should be checking your answers. This was on the calculation, some of the calculations that we did before spring break. So I'll go over that, and then I'll basically give you kind of an old test that I've used, and you can do that as sort of a practice assignment, and I'll mark that, so that'll be for marks as well. Okay, so we'll go over the answers to the quiz, and then you can work on the practice test and have that done for prior to Friday's class. Now, before we start, some of the questions didn't have the KSP value, so you did need to use this solubility product constant table. Okay, now if you don't have this table, then what you want to do is basically get it online. Okay, you can find that table if you just Google that solubility table at 25 degrees. You should find a similar table on Google. All right, so first question here, calculate the solubility of copper 2 iodate at 25 degrees. So that matches with the table. Okay, so there's the KSP value, so that you can find that in the table. Okay, and there's your saturated system, right? So there's the copper 2 iodate, and then there's the ions copper 2 plus and IO3 minus. And so what we do is we say let X equal the solubility of CuIO3 2. Okay, so that's the value of X. Therefore, Cu2 plus is also X because it's a 1-to-1 mole ratio, and IO3 minus is 2X. Okay, because of the 2 there. Okay, there's your KSP expression. Okay, so you substitute x and 2x, and then you're squaring it, so it becomes 4x cubed. And then you want to solve. So there's your KSP equal to 4x cubed. So what you want to do is divide this by 4, and then take the cube root of it. Okay, and so when you do that, you should get an answer of 2.58 to the negative 3 moles per liter. Okay, remember, moles per liter is the unit for solubility, or it could be in some type of mass per volume. Okay, and as I'm going through these, if something is that you're finding that I'm explaining is confusing, just again put it on the post, and then I can come back to this. Okay, so that's not a problem. Okay, next one. So we've got, we want to find the solubility product, so that's KSP for calcium oxalate in 50 milliliters. Okay, so there's your reaction. So we got to find the molar mass calcium oxalate. Okay, so the calcium's 40. There's 2 carbons, that's 24. There's 4 oxygens, that's 64. So your molar mass here is going to be 128.1 grams per mole. Okay, and so divide that to get your moles, and then remember you got to divide that by the volume, and it's in milliliters, so we got to change that to liters. Okay, so 0.05 liters, and then that gives you the the moles per liter, the solubility, and then the KSP. Um, so this is the solubility of the CaC2O4, and so both the calcium ion and the C2O4 2 minus ion are 1-to-1 mole ratios, so that's why these are the same. Okay, and so you just multiply those out and you get an answer of 2.3 times 10 to the minus 5. It's an equilibrium constant, so there's no units there. Okay. All right, next question. Okay, next question here. Will a precipitate form when 20 mils of 0.7 molar are added to 40 mils of 0.5 molar? Okay. Okay, so here's calcium bromide. Okay, so Ca2 plus, 2Br minus. So you've got 1.4 molar, right? Because we're starting with 0.7 of this calcium bromide, so that's 1.4 molar of bromide. Notice I don't care about the calcium, right? So here, what we're looking at is the precipitate that we're considering is the silver bromide, okay? And there's the KSP value there that you have to look up, okay? And now we have to, because we're mixing, we have to factor in the dilution, right? So we've got 1.4 molar, we've got 20 mils over a total volume of 60. So that's 60 is 40 plus the 20 mils. Okay, so that's where that came from. And then here's your concentration of bromine. Okay, so do the same exact thing with the silver nitrate. There's 0.5 molar, so there's 0.5 molar of the silver ion, and then multiply that by the dilution factor, 40 over 60, because there's 40 of this one, you get 0.33. So here, remember this Q value, that's called the trial KSP. We're going to use it to compare with that, the KSP. If it's the same, then the system's already at equilibrium. If it's greater, a precipitate will form. If it's less, then a precipitate will not form. And so here we get 0.156, which is bigger, and so therefore there will be a precipitate formation. Okay, because it is greater. All right, and then the last one here, the minimum amount of iron, and that should say iron 2 plus. I know on the practice quiz it said 2 minus, so this should be 2 plus over here. Okay, we've got strontium hydroxide. So for there's a reaction. So if you got 0.025 of the strontium, you got 0.05 molar of the hydroxide, a 2-to-1 mole ratio. So just make sure with all these reactions that we're doing, they've got to be balanced. Okay, and you got to factor in the mole ratio. The iron 2 hydroxide. So this is the same concentration. So there's your hydroxide. Okay, and then here's where we want to find the iron. So we'll let that be X. Okay, there's your again. You got to look up the KSP. Okay, so I think some of you might have gotten stuck here is if you couldn't find the KSP value. Okay, and but again, if you got stuck, then ask me on the post, and I would have mentioned that to you. Okay, so KSP 4.9 to the negative 17. Look that up. Equal to X times 0.05 squared. You don't need to double that again. It's already been doubled. And then 1.96 to the negative 14 is your the minimum amount of iron you need to start precipitation. So anything above that will also do precipitation. Anything below this will not be enough. Okay, so I'll stop there. Again, just a couple things here. One, get on the post, ask questions that you'd like me to go over. And then secondly, for the work that I'm having you do, make sure you submit your answers and you send it to me. Okay, so um, uh, for this class, what I want you to do is basically the practice test for the unit. On Friday's class, I will begin the next unit, which is the acid-base equilibrium unit. Okay, so what we have left here is acid-base, which is a fairly bulky unit, and then we have the electrochemistry or redox chemistry. Okay, so and that's a fairly big unit as well. So those are the two units that are remaining in the course. Okay, so again, just to repeat myself, please get on the post, send me questions, let me know if there's stuff you want me to go over, let me know what's confusing. Let's keep the dialogue open. Okay, and again, look after yourselves and the people around you. Okay, take care. Bye.